Throughout human history, we've built an incredible body of knowledge about the universe around us. However, we're only at the beginning of this journey. The universe is a twilight zone of secrets, unexplained mysteries, and black holes, shaped by unseen forces. In this video, we will reveal some of them. What lies beyond the universe? Does Planet 9 really exist? Is there life on Jupiter's moon? What did Voyagers 1 and 2 detect beyond our solar system? It is generally considered that the universe has no bounds, no beginning, no end. Perhaps after today, you'll no longer consider our universe synonymous with infinity. After all, what has a beginning, sooner or later, will find its end. The infinite nature of the universe suggests that it must be infinite, not only in terms of space, but also in terms of time, which means it would contain an infinite number of stars. If that were the case, our sky would be densely populated with stars and incredibly bright at all times of the day. However, the darkness of the night sky suggests that the timeline of the existing cosmos is not infinite. And so, according to this theory, the universe was created as a result of a powerful explosion from a point of densely packed matter and energy, also known as singularity. Mark a sheet of paper with a small dot, then try to crush the paper to the size of that dot. Now imagine before this Big Bang, our universe was contained in a space smaller than the dot you just drew. The amount of pressure within it was incredibly high, and it feels natural that eventually this presence would result in expansion. Just as the paper in your hands is trying to take its previous form, the universe expanded, albeit on an entirely different scale. And everything in the universe, past, present, and future, is the consequence of that event. Everything we see and feel, the matter that we're composed of, everything formed thanks to that process. So how was everything we see around us born from such a destructive process? At the beginning, in a millionth of a second, almost instantly, spread the extremely high-temperature substance, the plasma. From that emerged the elements that make up our world today, such as protons, neutrons, electrons. This process is known as baryogenesis or baryosynthesis. It led to conditions that made it possible for hydrogen and helium to form, which subsequently formed the stars. The life cycle of a star will form everything that our world is made of. First, let's talk about how we were able to have a glance all the way back to the start of the universe. And then we can discuss why it is so difficult to find its edge. To travel to the past, you'll only need a TV. And now that it's in front of you, watch. Without a signal, all we see on the screen are interference and white noise. But right now, you're watching a process that's a direct consequence of the Big Bang. Look closer. This is relic radiation of the universe, also known as cosmic microwave background, or CMB. In the 70s, the process of space exploration resulted in the discovery of a number of zones we could not see properly. Some of the images looked as if there was a lens flare. The strange thing was that all the cosmic sources of light known at the time, such as the dying or emerging stars, were too far from these flares. They couldn't have been the reason for this phenomenon. This is how the scientists learned about relic radiation, and what you're seeing on the screen is the effect of this radiation. This white noise is the real echo and voice of the early universe. When scientists set out to research this phenomenon, it became apparent that the radiation occurred at the very moment when the universe was first lit up by the emergence of chemical elements. We learned that this radiation is not related to the stars or other sources of light thanks to the WMAP probe. Thanks to WMAP, we were able to receive the first comprehensive map of relic radiation in the universe. More detail was added to the map thanks to the work of the Planck Space Observatory. Take a look at it. Doesn't it look like the previous TV image, but in color? This echo of the Big Bang is dispersed across the universe incredibly even. This is the light of the birth of our universe that's existed since the Big Bang. And thanks to this light, we're now able to see the true structure of the universe and realize the universe is finite. The things we are able to see or calculate using a computer model was called the observable universe, and the things that we can explore within it are known as the metagalaxy. So where are we within this system? Let's have a look. There's our home planet Earth and the solar system. The solar system is a part of the local stellar system. Along with the neighboring stars and their systems, we are part of the Milky Way galaxy. The galaxy itself is part of a larger group of galaxies. As we zoom out even further, we can see our place among other galaxies in the Laniakea supercluster. Seems huge, doesn't it? The final reference for scale will be the observable universe. In the grand scheme of things, we are only a tiny grain of sand. But even an entity of this size has its limits. We're facing the fundamental question. Everything that we see, is that the extent of the universe? How can we see beyond the light emitted by stars? Take a closer look at the map of the cosmic microwave background. The brighter spots signal the changes in temperature in space, which signifies where the star systems, galaxies, and supergalaxies can be found outside of our visual range. Is it possible to use relic radiation to see the entire universe? Think about the night sky. If you're on a brightly lit street or next to another source of light, such as a campfire, it's difficult to make out the faraway stars in the sky. Same principle applies here. Relic radiation illuminates the universe in all its glory. However, its light also hides the dark alleys of the universe. For example, the areas devoid of stars. It also hides black holes and places in our universe that have not yet been reached by light. Remember, the consequences of the Big Bang are still relevant. So is there anything beyond this edge? It seems that the answer to this question was found through the inflation theory. According to this theory, the bounds of our universe continue to expand at a rapid exponential pace, which leads to a conclusion that the universe cannot have a concrete boundary. Let's circle back to that piece of paper you crumbled at the start. Has it begun to unravel yet? It's obvious that sooner or later, it will come back to being the same size as the sheet you grabbed initially. The most elementary physics dictates that the inflation theory has its issues, because the laws of physics work in the same manner in every part of our universe. Even though scientists found countless things that confirm the rapid expansion of the universe after the Big Bang, as well as plenty of facts that suggest continuing expansion, that's far from being the big picture. For example, observations showed that galaxies and stars have an ever-increasing speed as they move apart from each other. Seemingly, this would confirm the inflation theory of the universe. Nevertheless, questions remain. What was happening when the universe did not yet exist? If the universe emerged from singularity, does that mean that there was a time before this singularity existed? If the same laws of physics apply in different parts of the universe, then why is the universe so large? Where did the energy necessary to create it come from? Doubts were always present, and the more scientists learned about the structure and history of our world, the more questions remained unanswered. The Big Bang Theory and subsequently the inflation theory were not able to answer these questions. Fortunately, there was a different theory that was recently proposed, which may be able to explain to us the things we see in the universe now, as well as things that happened before and things that will likely happen in the future. It is rooted in the idea that everything material in the universe consists of tiny particles which collectively make up something roughly similar to strings. For example, the smallest particle of light is called a photon, and it manifests as rays of light made up from many of these particles moving in a certain direction. We see this movement as light. Same principle applies to sound, gravity, heat, and so on. According to their theory, there is no beginning or end of the universe. There's just endless strings of matter that interact with each other. According to their scenario, the history of the universe is an endless cycle. But in this case, instead of starting a new universe, it denotes the next phase of its existence. According to their model, our universe emerged as a result of a collision of two three-dimensional worlds. So why can't we see this neighboring world? According to string theory, in addition to the three-dimensional world visible to us, matter exists in several additional dimensions. And so it's not unreasonable to theorize that two three-dimensional worlds could collide within the framework of an additional hidden dimension. The boundary begins where our universe collides with other universes in its motion, interacting and receiving the necessary impulses for its development cycle outside the three-dimensional world we are accustomed to. Who knows what are the laws of physics beyond our universe? Since Pluto lost its planet status, scientists have not abandoned their attempts to detect other large objects on the edge of the solar system. After all, there is something beyond the orbit of Neptune that significantly affects the trajectory and revolution of celestial objects like asteroids and dwarf planets. And this isn't the kind of something we can detect with telescopes. Recent research suggests it could be a miniature black hole, or even a cluster of dark matter. In this video, we'll examine the mysterious ninth planet, its properties, size, and whether it is a planet at all. The question about the existence of the ninth planet became especially prevalent when scientists closely studied the movements of trans-Neptunian objects in the Kuiper Belt, an area on the edge of the solar system similar to an asteroid belt. Astrophysicists Konstantin Batygin and Michael Brown studied 6 distant objects in the Kuiper Belt, dwarf planets and planetoids, including the dwarf planet Sedna. They found that the objects followed elliptical orbits pointed in the same direction, but moving at different speeds. This was a rather unexpected discovery, and Brown even made this analogy. This kind of result is if there were a clock with 6 hands moving at different speeds, but as soon as you look up, all the hands are in the same spot. Brown implied that this type of event is very unlikely, and on top of that, the orbits of these 6 objects are tilted at the same angle, about 30 degrees downward in the same direction relative to the plane of the 8 known planets. The chance of this happening is about 0.007%. The first proposed theory was the presence of certain objects near the borders of the Kuiper Belt that would affect gravity. Therefore, if that were the case, the mass of the belt should have been 100 times greater than it is today. Computer simulations using a small planet have shown that its mass would be insufficient to align objects in this manner. However, if you run a similar simulation with a massive planet the scale of Uranus or Neptune, the mathematical model converges and practically duplicates the real-world calculation results. The work of Batygin and Brown sets limits on the possible mass of the ninth planet, the location of its orbit, and its position in the sky. According to calculations, the mass of the planet is 5 to 20 times greater than the mass of Earth, and its diameter is 2 to 4 times larger than our planet's. To see this planet directly through a telescope is almost impossible. It is too far to register in our visible spectrum, so we have to search for it using its faint infrared glow. However, with a mass of only 5 Earth masses, it wouldn't give off much heat. Additionally, such a distant planet would revolve around the Sun very slowly, so it would be impossible to detect its movement with observation alone. It's only possible by comparing images taken at different times, and this may take dozens of years. And unfortunately for astrophysicists, it's most likely that right now the planet is the furthest removed from the Sun in the northern hemisphere of the sky, with the radius of its elongated orbit on average in range from 380 to 980 astronomical units. And even all of the data collected so far does not provide a complete picture of the potential location of the mysterious planet. The search area is approximately 600 to 800 square degrees in the night sky. For reference, the full moon only occupies 0.2 square degrees in the sky. In an attempt to narrow down the planet's orbit, the researchers compared simulation results with real Kuiper Belt objects. A 4-billion-year-old model of the solar system was built. The scientists wanted to understand how the gravitational pull of the largest planets and the 9th planet could affect the orbits of thousands of objects in the Kuiper Belt. Although Batygin and Brown actually prove the existence of a certain object that influences the position of other celestial bodies, recent research conducted over the years 2020 to 2022 have cast doubt on the existence of a massive planet. In a relatively recent study from 2021, critics of the Batygin-Brown theory have discovered about 300 new objects in the region of the Kuiper Belt, where the Batygin and Brown theorized the presence of the 9th planet. Astronomers scanned the better part of the sky with the 20-foot Atacama Space Telescope in Chile in search of the new planet and spent 6 years studying 87% of the sky accessible from the southern hemisphere. Reportedly, a detailed examination of the orbits of objects in question revealed that every case of orbit synchronization can be explained by known physics effects except for 2 celestial bodies. But even these 2 anomalies are an exception out of 300 objects, and in a way they confirm the new theory. Why do discoveries in these orbits not coincide with Batygin and Brown's predictions? The answer may be that the 9th planet theory is simply incorrect. However, the nature of the strange behavior of the orbits of some objects in the farthest reaches of our solar system, hypothesized by some astronomers to be shaped by an unknown 9th planet, can instead be explained by the combined gravitational force of small objects orbiting the Sun beyond Neptune. The alternative explanation, Planet 9 hypothesis put forward by researchers, proposes a disk made up of small icy bodies with a combined mass as much as 10 times that of Earth. When combined with a simplified model of the solar system, the gravitational forces of the hypothesized disk can account for the unusual orbit architecture exhibited by some objects at the outer reaches of the solar system. The researchers created a computer model of the detached TNOs as well as the planets of the solar system and their gravity and a huge disk of debris past Neptune's orbit. Astrophysicist Antranik Safilian allows if you remove Planet 9 from the model and instead allow for lots of small objects scattered across a wide area, collective attractions between those objects could just as easily account for the eccentric orbits we see in some TNOs. Earlier attempts to estimate the total mass of objects beyond Neptune have only added up to around 1/10 the mass of Earth. However, in order for the TNOs to have the observed orbits and for there to be no Planet 9, the model requires the combined mass of the Kuiper Belt to be between a few to 10 times the mass of the Earth. Another team of scientists used the Infrared Astronomical Satellite, the IRAS, and the Akari Infrared Telescope to search for the 9th planet. 2 surveys were performed and photographed over 20 years apart, giving any hypothetical planet enough time to move to a slightly different part of the sky. The scientists assumed that any distant planets would be quite close to the equatorial plane of the sky and then studied the data marking potential planets. They have found over 500 candidates. Judging by the energy distribution of their spectra, most of them have orbital distances of less than 1,000 astronomical units. This means that most of these objects were either inside or near a faint nebula. A nebula is a cloud of interstellar gas that's difficult to see with the naked eye because it emits infrared light, or simply put, heat. It turns out that all the discovered candidates are not planets at all, but rather echoes of a faint nebula. A large planet, clusters of small objects, or a glimpse of a distant galaxy. These are perhaps the simplest explanations for the unusual behavior of trans-Neptunian objects. Scientists ask themselves a logical question. What kind of object would have enough mass to change the orbits of other celestial bodies, yet not be visible to us? This prompted theorists to consider a radical hypothesis. What if the ninth planet is a small black hole that can be detected by theoretical radiation emitted around its edges, the so-called Hawking radiation? There is a contradiction that relates to the mass of such an object. Since it is believed that only the most gigantic stars are large enough to form a black hole, the black holes they would leave behind would have a minimum mass of around 5 times greater than the Sun's mass. But what if the extreme conditions of the early universe made it possible for smaller black holes to form? A group of astronomers from Harvard University plan to start their search for such objects as early as 2023. As part of the Legacy Survey of Space and Time, the LSST project. To help them find black holes in far corners of the solar system, astrophysicist Avi Loeb developed a method to search for flares that occur when a black hole collides with small objects in the Kuiper Belt and the Oort cloud, a region that could potentially contain several trillion bodies surrounding our system. The researchers say that sometimes the objects within the Oort cloud, such as comets, can interact with lurking black holes, creating a visible flash of light, possible for Rubin's observatory to detect. Thus, if scientists could confirm that a small black hole the size of a grapefruit with a mass of 5 to 10 times the mass of Earth orbits the Sun, this could provide an answer to one of the greatest mysteries of modern cosmology, the formation of black holes. However, there is another theory, most exotic and yet just as deserving as others. What if out there at the edge of the solar system there's an object made of dark matter? We see evidence of dark matter all around us. Stars that revolve too fast around the centers of their galaxy. Galaxies that move too fast within their clusters. A new hypothesis now suggests that most of the dark matter can concentrate into objects the size of Neptune, the so-called dark matter planets. Although these planets remain invisible to us, they can create an atmosphere out of helium and hydrogen. And this can lead to the fact that reaching critical temperatures would trigger nuclear fusion inside the planets, which would help us discover them. Dark matter forming into planets may explain why no object with a mass approximately equal to the mass of Neptune has been discovered in the aforementioned research. Scientists believe that if dark matter planets exist, they clearly formed when the universe was very young and remained static for billions of years. In the early universe, the temperature was too high, which prevented the formation of larger objects. However, dark matter does not interact with ordinary matter nor light and could therefore freely assemble into such, quote, planets. According to this theory, instead of being evenly distributed throughout the galaxy, most of the dark matter will be inside these relatively compact spheres, with masses ranging from a mass of an asteroid to the mass of Neptune. These hypothetical dark matter planets may have first accumulated a layer of helium, since it was the first chemical element to break away from the plasma state of the early universe, and later attracted hydrogen gas, creating a dense atmosphere around the helium similar to the layers of gas around giant planets. What would we see inside a planet like that? It's hard to say. Submerging into such a planet would be very strange. A bright layer of hydrogen would be warm since it's gravitationally bound to a dense object. The friction would cause it to glow. After the layer of hydrogen, we would reach the helium underneath, and as soon as we passed through the helium, we would see nothing. Absolute emptiness. The core of the dark matter planet would be completely invisible. You'll find yourself surrounded by a membrane of luminous hydrogen-helium plasma. The flash from the ejection of matter could compete with a supernova in its brightness. In conclusion, let's address the expediency of the search for the mysterious ninth planet. Although searches have so far not revealed a single planet at the edge of the solar system, this does not mean that the search was completely in vain. The ninth planet theory has sparked an unprecedented surge in research into the Kuiper Belt and other trans-Neptunian objects. The search for Planet 9 may eventually lead to something even more significant for the scientific progress. For example, Batygin claims that the discovery of the ninth planet, which seems so strange to us, would actually make our solar system more like other planetary systems. We quote, "One of the most striking discoveries about other planetary systems was that the most common type of planet has a mass in the range between the masses of the Earth and Neptune. Until now, we thought that the solar system is missing exactly this, the most common type of planet. Maybe, after all, our system is not as unique as we thought." By now, we have all become accustomed to the idea that life originated in the ocean. But certain questions still make scientists have fierce arguments with each other. For example, how did life transition from water to dry land? Why would a mass meteorite strike be useful? Is collision with another planet important for the development of life? What did Earth look like throughout the first millions of years of its existence, and what obstacles did it have to face? Some of these questions already have answers, and we will share them with you right now. Life that originated in the water and later made its way to dry land appears as a very plausible theory. After all, the oceans currently cover more than 70% of the Earth and contain many different organisms, some of them studied so little that scientists still continue to discover new species. Once on land, these life forms successfully adapted and evolved to eventually become human. Everyone remembers Darwin's theory, where a fish suddenly decided to spend its vacation on dry land. The modern scientists explained this theory. Fun fact: no matter how many refutations of Darwin's theory you read, scientists take this theory as a starting point just as often. The main question is, what is required for a life to form except for the ocean? To answer this question, we must travel to the distant past of the solar system. The process of creation of the solar system is similar to our neighboring star systems. At some point, about 13.6 billion years ago, the Big Bang happened. According to scientists, it was responsible for creating the universe as we see it in telescopes. And the consequences of this event led to the first chemical elements forming. Hydrogen, which compressed and heated under the pressure of the energy from the explosion and turned into a new element, helium. We refer to this bunch of compressed hydrogen which turns into helium as a protostar. But the protostars did not stay with us for long. The main benefit of their existence is the emergence of new chemical elements, which became the building blocks for the origin of life. First and foremost, it led to the emergence of ordinary stars. Every star has a life cycle throughout which the star is akin to a factory. Something is burning, there is some smoke, and streams of resources are flowing through to produce something. Simultaneously, all of these processes affect the ecology and environment. So our sun, like any other star, does the same thing, but on a cosmic scale. And then the life of a star factory is pretty prosaic. It either expands to a supernova or transforms into a red giant or a dark dwarf, followed by attenuation and death. Alternatively, a star can turn into a black hole. We know for sure that the Sun will become a red giant, eventually expanding to encompass nearby planets, including us. However, we still have 5.5 billion years before that happens, so we'll have enough time to finish watching our favorite TV shows. What is so special about our solar system? Scientists theorize that the Sun was created by a supernova being destroyed not far from the future solar system. Thus, our star, having arisen from compressed clouds of gases, will have eventually absorbed such a high amount of matter due to gravity that it will be enough not only for its existence, but also for the creation of the entire solar system. Everything that was not a part of the new star began to revolve around it, flattening and acquiring the shape of a disk. That's a huge amount of matter. Some of it will be lucky to become a planet, and some will leave the Sun's immediate orbit to become a comet or a dwarf planet. The future cradle of humankind came to existence somewhere around here. At the start of its life, Earth was something like a stew of lava, rocks in a liquid form, and crazy mixtures of gases released during the melting process. Near Earth's surface, the temperature exceeded 1,200 degrees. There was no air, only carbon dioxide, nitrogen, and steam. Moreover, the planet was being continuously bombarded by comets and meteorites, some attracted by the planet itself and some attracted by the Sun. This is where the water particles that eventually land on Earth come from. But at this point, there is no talk of any life. Earth receives the most powerful blow in its history, but also the most useful, as it turned out later. A planet the size of Mars, which was later named Theia by the scientist, crashes into us. The result of this collision is the formation of the current shape and size of Earth. But even more importantly, the fragments form into our satellite, the Moon. Initially, it was much closer to us, 13.6 thousand miles. This will have an effect later on. The importance of the Moon will become more evident as Earth cools down. Over time, Earth's temperature began to lower, which led to Earth's crust forming, a thick layer of everything that our planet collected due to gravity as it was forming. And after the cooling process, only the very core of the planet, molten iron, remained hot and liquid. It is the activity within the core that creates the magnetic field around Earth and keeps it at its stable moving pace, both around its own axis and around the Sun. As the temperature kept dropping, the planet experienced its first rainfall. Around 3.8 billion years ago, it was subjected to a meteor shower, the remnants from the formation of the solar system bombarding Earth. But inside these bombs, there was also something useful, namely water. Those are not yet the kind of rains we're used to. At the time, the speed of Earth's rotation was so high that a day only lasted 6 hours. However, thanks to that very useful rain, the first ocean is formed on Earth. Meteor showers lasted 20 million years, so the low water content in each individual meteorite was not a problem. Quantity led to quality. At this stage in Earth's development, scientists had a question: where did water actually come from? There are two theories regarding this. Some believe that all the water was brought to us by meteorites. A second theory suggests that there was already water on Earth. The argument was solved by time and new discoveries. Both theories turned out to be right and wrong at the same time. Studying the soil from the Moon's surface revealed that the then young and active Sun burned everything that could evaporate from the planets, including water and gases. And so the scientists still cannot definitively say whether there is more water of meteoric or terrestrial origin present on Earth. And most likely, they will never be able to answer that question. But the main thing is that the collision of Earth and Theia became a catalyst for the beginning of the cooling process of the planets, and subsequently the formation of Earth's atmosphere, which would serve to protect it from the Sun. The existence of the atmosphere became the shield that maintains everything needed to create life and doesn't let anything harmful in. How did the atmosphere form? Earth has cooled down, but the volcanoes are still active. Due to this volcanic activity, water evaporates, turning into clouds, which then turn into rain. For millions of years, rains fall to Earth's surface, pooling into lakes, then seas and oceans. And this worldwide ocean was very stormy. You know how the moon influenced the tide. At the time, the moon was much closer, and its rotation around Earth caused such powerful ocean storms we could hardly imagine the scale. Some waves reached no less than 1,000 feet in height. Meanwhile, the winds on Earth were nearly as fast as the speed of sound. And so the ocean is raging, the storm is at full swing. Where is life? Contemporary theories generally agree on one thing. Back then, Earth's oceans were an ideal place for the emergence of life. But there are several problems. The main question is, how did organic matter, that is, chemical elements that are the building blocks of life, come to exist under these conditions? Let's break it down. Water in Earth's atmosphere at the time, specifically nitrogen, hydrogen, and carbon dioxide, are elements from the inanimate part of the chemical elements, the so-called inorganic chemical elements. To answer this, let's look at the theory that was developed by Oparin, an academic from the USSR in 1924, as well as a similar theory put forward by a biochemist from the UK named Haldane in 1938. In essence, these theories are simple. The ocean of that time was constantly replenished with organic substances from the atmosphere, which was constantly struck by lightning thanks to the endless storm of that period. It was under the influence of these electrical charges that these elements in the atmosphere turned from inanimate, inorganic, into living, organic, and fell into the water. Once they were in the water, the particles slowly gathered together and formed a broth of organic matter, which would subsequently develop into living organisms. The way these particles behave was similar to the behavior of cells. They can grow, divide, and absorb other chemical elements. But the truth is, the organic matter only acts as the building blocks of the body. Creating life itself requires a team of workers and a foreman to bring everything together. The foreman of our cells is our DNA, an entire library of how everything works, from reproduction to building complex structures from sets of cells. The workers performing the task are RNA. The Oparin-Haldane theory is similar to the story about Frankenstein's monster, whose inanimate matter was also brought to life by a lightning strike. The main thing that we know is that life arose somewhere in the ocean and for 300 million years existed in the form of single-celled organisms. They were not particularly in a hurry to turn into people, were they? But to be frank, the conditions of the ancient Earth would not have given something more complex a chance to develop. The single-celled organisms that existed then were prokaryotes. The main difference between them and us is that their organism consisted of one cell without a protective membrane, and in most cases without a nucleus. A good example of the currently existing prokaryotes is bacteria. On Earth, first, oxygen came to exist in sufficient quantities to begin to form the atmosphere in which we now live. And then, within 1 billion years, somewhere between 3.5 and 2.5 billion years ago, a new miracle took place. Single-celled organisms, even in such a literally toxic atmosphere, have learned to use the energy of light to convert water, carbon dioxide, and solar energy into their first food, glucose. The byproduct of the process produced even more oxygen. We refer to this miracle as photosynthesis. After the cooling of the Earth and the formation of the ocean, a terrible thing happened. 2 ice ages took place. The first, known as the Pongola glaciation, lasted 500 million years. The second, the Huronian Ice Age, was slightly shorter, but it almost exterminated life on Earth. The Huron glaciation lasted 300 million years. It was caused by an oxygen catastrophe. It happened due to the fact that thanks to photosynthesis, unicellular organisms began to release so much oxygen that it led to the extinction of all unicellular organisms that existed without oxygen. And so aerobic organisms, the organisms that need oxygen to exist, became dominant life forms on the planet. Next, prokaryotes continued to evolve into eukaryotes, both our closest and the most ancient ancestors in terms of cell structure. Eukaryotes were able to compete, absorb, and destroy their own kind. They used solar energy as the main source of life and were also able to reproduce. Then there was the era of the dinosaurs that went extinct due to a meteorite impact, but the birds and half of the other species survived. Life has finally conquered the land. Let's sum it up. Earth has a unique combination of factors contributing to the origin of life. The question about the origin of life remains unanswered, but we have some intriguing clues. Water and the world's oceans are the main source of these answers, but not the only source. Our oceans are unique. They are a result of Earth's planetary evolution. We live in a beautiful time when discoveries related to the transformation of inanimate elements into the living matter are closer than ever. We even envy ourselves a little. After all, the secret of life may soon be revealed. Is life possible anywhere other than our home planet? And what if we tell you that there is a place within the solar system where we can find an ocean full of water twice as large as any of the Earth's oceans? This ocean is hidden under a layer of ice dozens of miles in thickness. However, 125-mile geysers push their way up from under this ice shield, and the atmosphere of this world consists of oxygen. Sounds familiar, doesn't it? That's why today we'll tell you about a place that's almost literally in our backyard right in the solar system. We are heading to Jupiter to discover the depths of its icy moon, Europa. Europa is one of Jupiter's 7 satellites. It was discovered in 1610 by the famous astronomer Galileo Galilei, along with 3 other satellites that are now referred to as the Galileo satellites. Back then, this discovery made a lot of noise. But even to this day, that location remains one of the focal points of interest for the scientists of the world, from astrophysicists to biochemists. Jupiter and its satellites are now referred to by the scientists as the miniature solar system, and there's a good reason for that. Each satellite has unique characteristics, from volcanic activity on Io to methane lakes on Ganymede. There's plenty to study on each moon. These satellites are still the center of attention, which is why in just a few weeks a new mission titled JUICE is going to head towards Jupiter. Its primary objective is to observe and study icy moons of Jupiter. We're already used to the fact that whenever we find water on our planet, we also find life. It is in search of water that the JUICE mission will set off on his journey to the icy surface of Europa and its siblings. But is water the only thing required for life to exist? We can't accurately estimate the conditions for life to actually exist in the universe. But there is one set of conditions that we believe leads to life, flourishing in its many forms and sizes, and that is the conditions on our planet Earth. So what conditions are these? Water is the #1 ingredient among the list of ingredients required for life as we know it to exist. It's needed to dissolve and supply nutrients to organisms, while also allowing the waste products of these processes to be disposed of. Many factors indicate there is water under the ice on Europa, and one of them comes from a similar situation on Earth. It turns out the double ice ridges and cracks visible on Jupiter's satellite are similar to those in Greenland. These irregularities are the potential evidence of the existence of liquid water under this ice. On Earth, such ridges are caused precisely by the presence of water cushions within the ice and under these breaks, which gave the scientists the idea that these cracks are similar to the ones on Earth. As for the chemical elements necessary for the creation and maintenance of life, it turns out they are present on Europa. Satellite photographs taken by the Voyager probe makes it possible to study the structure of ice and confirm that the ice is covered with a considerable amount of salt deposits and heavy metals such as magnesium, which incidentally is the reason for the hue similar to the color of blood. We observe similar conditions on Earth in Greenland, where salt comes to the surface of the ice as a result of volcanic activity. On Europa, however, the movements of ice strongly resemble the tectonic activity, indicating they were possibly caused by it. The last ingredient we need is a source of energy. The Sun, which is an energy source for our planet, can hardly be considered to have any real influence on Europa's ocean. Still, the ice covering this moon reflects a huge amount of sunlight, and the distance to the Sun is 6 times greater than the distance from Sun to Earth. But the radiation exposure from Jupiter on each revolution around the planet is most likely the source of energy in question. The influence of Jupiter's radiation on the ice leads to the release of oxygen, which is what the atmosphere of Europa mainly consists of. Oxygen is the most important element in the organic chemistry processes on Earth, and if it somehow gets under the ice on Europa, it can become the fuel required for life to develop, even if it's just bacteria. It is also possible that on Europa there are life forms that are not dependent on oxygen. The so-called anaerobic organisms exist on Earth, and in fact, in the early history of the planet, they were the dominant form of life. The last factor that's expected to be found through further study is the volcanic activity in the crust encircling the core of Europa. In the depths of our ocean, at the borders of continental plates, hydrothermal flows break out the ground. If we take a closer look, we will see that the population around these places is incredibly high and includes some amazing life forms alongside various corals. It is believed that Europa's rotation around Jupiter causes the same processes at the bottom of the Moon's ocean, and if so, it is possible that life can be found near these hydrothermal zones. And so, we have all the necessary ingredients to create life. Every object in the solar system is bombarded by meteorites, but on Europa, these traces are either incredibly faint or absent. What do you say to that? The researchers noted that some of the dark stripes have opposing sides that fit together very well, kind of like puzzle pieces. Furthermore, between these cracks, there was some dark icy material that seemed to flow into the cracks. This has made scientists speculate that the surface of this moon has been in active motion at least recently. And so the absence of large impact craters indicates that Europa's surface was relatively young. At the same time, this means that something had erased the traces of any impacts. There are 2 possible ways to explain this. As they escape from under the crust, the streams of ice erased the traces of the meteorite hits, or the ice sank under its own weight along with any traces of the impacts. In both cases, it means that the icy surface is very dynamic, almost like there's a warmer layer underneath. The scientists also found that the cracks they see do not match the predicted patterns that would form as a result of gravitational tides as Europa orbits Jupiter. There was a missing piece of the puzzle. This led to a conclusion that Europa's ice crust was not so solid. It was determined that if Europa's surface moved independently of the inner layers, the patterns would match very well, which would be the case if there was a layer of liquid or slightly warmer ice between the surface and the depth. This spurred the scientists to learn more about Europa, and soon they finally had an opportunity to do that. The Galileo probe was launched in 1989 and entered Jupiter's orbit in 1995. Galileo's main mission included observing each of Jupiter's 4 satellites during repeat flybys. The information sent by Galileo about Europa was so intriguing that the mission was extended to make a total of 12 close flybys near the icy moon. One of the most important pieces of data that caught scientists' attention showed that Jupiter's magnetic field collapses in the space around Europa. Scientists believe that the most likely reason for this magnetic anomaly was there is an ocean full of salt water under the icy surface of Europa. Only a large body of water would have such an effect. At this point, scientists were more than sure that there was an ocean on Europa. However, this was only the beginning. Exploring Europa got even more intriguing after some research of the Antarctic ice shelf. A new and truly stunning type of snow was discovered there, and it appears the same kind of snow could be falling on Europa. Surprisingly, it seems to fall upwards. How does it work? It's simple. The snow itself is lower in density than salt water, both in the Earth's oceans and on Europa. And the most amazing thing is that on Europa, due to the thickness of the ice, the snow most likely rises from the bottom up under the crust, possibly forming the same kind of mountains as on Earth, but upside down. The next thing hinting at activity under the ice were the geysers bursting from under the crust. Over the past 10 years, they've been recorded 3 times by scientists. These are bursts of ice reaching at least 125 miles in height, according to calculations. How does it happen? Scientists estimate that the depth of the ocean is about 35 to 65 miles, and the thickness of the ice crust above it is about 12 to 20 miles. It is precisely the relationship between the subglacial ocean and the ice lid during Europa's revolution around Jupiter, namely their friction and increasing temperature, that causes the ice to crack and display those cracks. Ice geysers periodically break out from the cracks consisting of warmer ice or even water. One of these geysers was captured by Galileo. Unfortunately, there was no way to collect samples of this substance. At the same time, it is also important to point out in the process of formation of such cracks, oxygen from above Europa's surface gets under the ice crust. This is yet another factor that speaks to the possible existence of life on Europa. A magnetometer on board measuring the strength and direction of Europa's magnetic field would allow scientists to determine the depth and the salinity of its ocean. The thermal equipment will scan Europa's surface for recent eruptions of warmer water, while the remaining tools will look for evidence of water and tiny particles in Europa's rarefied atmosphere. By collecting these samples, scientists will be able to study the satellite's chemical composition in more detail, painting a comprehensive picture of Europa as a whole. This will probably eliminate the need to drill through the ice and extract this information on the next mission. It is expected that once the probe reaches its destination and begins to revolve around Europa in 2030, the equipment will be able to do more than just understand the composition and structure of the moon in detail. After the Hubble telescope observed a water plume over the south pole of Europa in 2012, scientists hope that a new ice geyser will be detected during the flyby and that it will be possible to collect samples. The main purpose of the mission is to determine over the course of the planned 45 to 50 flybys if there are places under the ice crust of Europa where life could exist. The more detailed photographs of the satellite will allow scientists to select points of greatest interest for further observation. They plan to get as close as 25 miles from the surface. For comparison, the Galileo only managed to get 160 miles away from Europa. Of course, it would be nice to get closer, but the main obstacle for such task is the incredibly harsh radiation field of Jupiter, which would not allow the probe to stay in its vicinity for a long time. Another problem with this study will be the lack of energy. There will be solar panels on the probe, but the distance from the source, the Sun, will affect the performance of the system as well as its capabilities. But even those planned trios will be enough for a detailed study. Scientists are already planning another project to follow the Clipper mission and processing of the data it will collect. They want to land a robotic probe on Europa that will try to penetrate deeper into the ice, and perhaps that's when extraterrestrial life could be found. We just have to wait and look forward to new discoveries. Not so long ago, one of the Reddit threads provided information about the Voyager probes. In this post, an unnamed NASA staffer told the readers that the Voyager 1 probe didn't just stop transmitting the signal about its location as claimed by NASA. The user also said that the probe registered some mysterious humming sound, which reportedly contained a message in Morse code. When they decoded the message, they recognized the sounds from the golden records played on repeat, as if someone or something found the probe and was trying to communicate. NASA has not commented on this story. The story itself is pretty mystical, just like the story of Voyagers, full of revelations and frightening discoveries. But most importantly, where did it all take place? Where the knowledge about space ends and the theories begin, beyond the heliopause. But let's start at the beginning. How did humanity come to research one of the biggest mysteries of space? And what was the status quo before this discovery? 1977. The Voyager 2 and Voyager 1 probes have left our planet, beginning their journey towards the faraway gas planets of the solar system. The mission was expected to take 4 years, however, since then it went way beyond its original task, and now the probes explore domains that no one even hoped to reach. We should mention that initially the main mission of the Voyagers was to study and photograph the remote planets of the solar system: Jupiter, Saturn, Uranus, and Neptune, 2 each. The timing of the start of the mission was not selected randomly. It took place exactly when there was a rare and unique opportunity to visit all of the furthest planets of the solar system, since they align to be relatively close to each other. And this only happens every 176 years, so the scientists did everything in their power not to miss this chance. But how does it work? Essentially, the planets pass the probes from their zone of responsibility to the next planet, while remaining as close to each other as possible. At the same time, the probes set some unique records. Voyager 1 set a record as the fastest moving controlled object propelling away from Earth. Nothing ever left us quite so fast. It is also the furthest removed object created by humans. Voyager 2 has something up its sleeve too. It is the first and only probe so far to have visited all 4 giants of the solar system: Jupiter, Saturn, Uranus, and Neptune. The probes had an additional task: to study interstellar space. But what is that? To make it really simple, it's a place where the sun's influence, such as its gravitational pull, warmth, and energy, is completely absent. The place where such influence is predominant is called the heliosphere. The area where the sun's energy and gravity is present is defined as the solar system. We're yet to see if these probes can defy the heliosphere and leave the solar system. First, let's take a look at what's inside the Voyager probes. First and foremost, they're packed full of computer systems. Even though they were made back in the 1970s and your smartphone's processor is much quicker and more efficient, these systems are unique. Their main feature is that they can be reprogrammed and rewritten indefinitely, which is what scientists have been doing. What for? As the probes move further away from Earth, the number of systems needed for maintenance and task performance changes. In essence, Voyagers are like transformers, even if they're quite primitive. Depending on the task at hand, a Voyager probe can take photos, study the complex space energies, and record where it is in relation to Earth. And that's just a small part of the probe's functionality. NASA, who are in charge of the probes, disable any redundant systems to redirect the power and keep the Voyagers charged, allowing them to stay with us longer. For example, right now the camera systems on both probes are off. The Voyagers are expected to celebrate their 50th birthday in 2027, still remaining in contact with Earth. The power system on the probes is also unique. It's similar to an ordinary car, except instead of gas, it's fueled by a radioactive element. The creators of the probes promised a 10-fold quality guarantee on all systems. Considering that the probes are now over 40 years old, you could say that promise was fulfilled. And finally, the most important part of the probe are the tools designed for space exploration, each one with a unique purpose, providing us with their one view of the cosmos. And so the main mission was for the Voyagers to explore the furthest planets of the solar system. One of their primary results was supposed to be a collection of unique images of the following planets: the volcanic eruptions on Io, a satellite of Galileo, which is in turn one of Jupiter's satellites; the famous rings of Saturn, which are neither solid nor liquid but a collection of watery ice. The strongest winds in the solar system were recorded on Neptune, reaching about 1,370 miles per hour. The famous picture of Earth from space, the legendary pale blue dot, is the furthest picture of Earth ever taken. That was the result of the Voyager's journey through the heliosphere. But what boundary did they have to overcome, and what difficulties awaited the probes when they tried to leave the solar system? Let's take a closer look at the heliosphere and the heliopause, and why moving beyond the boundaries of the solar system is a pretty difficult task for any object. Before the Voyager's research, any knowledge about the heliosphere could be classified as theories and assumptions. For example, it was thought to be shaped as a sphere. But the data about the speed of the solar wind, the influence of magnetic fields, and the data about its contents were unavailable to science. We also did not know where it begins or where it ends, and certainly whether or not we can go beyond it. Now let's talk about the terms. The sphere of influence of the solar wind and the sun's gravitational pull is known as the heliosphere, and we don't know the bounds of the heliosphere yet. A place where the solar wind is balanced by the interstellar wind is the heliopause. It is not yet possible for us to comprehend the size and shape of the heliopause. The best way to envision the heliopause is located in your kitchen or bathroom. Turn on the tap and take a look at the place where the water hits the bottom of the sink. The area where the water is flowing along the surface of the sink is interstellar space. The place where the water disperses due to the impact is the heliosphere. The thin border where the falling water runs into the flowing water is the heliopause. Scientists divide the heliopause into a bow shock, the place where interstellar space scatters about it, and a main shock wave where the solar wind is slowed down by the impact of interstellar space. What does the heliopause look like? Thanks to the traveling probes, we know much more about it now, but still not enough. Voyager 1 and Voyager 2 crossed the heliopause at different points, located a different distance away from Earth. It showed that the resistance was different at varying exit points, as well as other conditions. And here's another bit of nuance. For a long time, Voyager 1 couldn't even definitely prove to the scientists that it had crossed that border. Where are we as we fly through space with our heliosphere? We are within an interstellar cloud. Around us, several similar clouds. Right now, we are approaching the edge of our native cloud. It is throughout its existence within this cloud that it became the solar system as we know it. In 3,000 years, we will exist in new conditions, in the so-called G cloud. Voyager 1 sensors recorded these changes in the space weather, and their readings proved that the probe did indeed cross the bounds of the system, as the echoes of the storms collided with a much denser environment than that in which Voyager had previously been. That is, the probe was already outside our heliospheric bubble, whereas the crossing of the heliopause by the Voyager 2 went much smoother. Its plasma device was in working order, and it registered the crossing in 2018, simultaneously confirming the data recorded by its sibling. Right now, scientists are getting more and more questions that cannot be answered. To begin with, when crossing the border, Voyager 1 transmitted absolutely unnatural data, as if it was breaking through something very dense. Moreover, the data showed that it had crossed the borders more than 5 times in a row. What was stopping it? What don't we know about the density of the heliopause? Some scientists believe this was a natural process, and the probe simply could not break through the boundary for a while. But the oddity's in there. The coordinate system, according to scientists, seemed to have gone insane. So much so that it was unclear whether Voyager was moving or if it was frozen in place. That strange Reddit story told at the beginning of the video is likely based on this information. After several checks, it turned out that the probe remained operational and did not experience any additional malfunctions. Neither did it switch to safe mode. Despite the fact that the equipment continued to act crazy, the probe itself obediently carried out commands and continued to transmit signals. So what actually happened? Scientists dispelled any mysticism quite easily. They believed that since the probe was in a place it was not ever expected to visit, such malfunctions in the work of the equipment are far from the worst thing that could happen to it. But what lies behind the formal answer? We are yet to find out. Now the probe is responding to commands from Earth, but the issues continue to this day. No one knows what happens to it there, beyond the influence of solar energy. According to some of the versions, the cause of the malfunctions are the old age of the probe, or the damage sustained in the process of traveling through the heliopause. But the mystery of Voyager 1 does not end there either. Some time ago, a signal came from outer space, and it's not the friendly wow the scientists hoped for in the 1970s. The signal is a low-frequency humming sound transmitted by the sensors of the Voyager 1. The nature of this sound is yet to be unraveled. The most common explanation is that the sound is the amalgamation of various vibrations of interstellar space. After all, Voyager is now slicing through space at hypersonic speeds. Some scientists believe that this signal happens in connection with the so-called foam effect. When moving, the plasma and interstellar matter crash into the heliopause and turn into a kind of foam, similar to sea foam from the waves hitting the shore. But where is the truth? Until now, neither astrophysicists nor other scientists have a clear answer to this question. After all, their knowledge is limited by Voyager 1. But everything indicates that Voyager 1 will still have time to surprise us with new discoveries on the other side of the border. Right now, both probes continue to transmit information about interstellar space. They measure the electron density by registering radio waves produced by solar flares. These eruptions are expected to become more frequent as sunspot cycle peaks in 2025. The current data shows that the density of interstellar space has increased even compared to the space immediately after the heliopause, although logic suggests it should decrease because the border has already been crossed. Strange, isn't it? What are the Voyager probes up to next? Voyager 2, which still has a working plasma device, will monitor the temperature of interstellar matter. Most likely, this temperature will decrease. Astronomers expect it will go as low as 7,500 Kelvin. However, it is still unclear what the data will show. The ultimate goal now for these twin probes is to take a sample of the untouched interstellar medium, a space so far removed that the heliosphere has little to no effect on it. For now, we wish the Voyagers to stay warm as long as possible and delight us with new discoveries.